AI agent development tools and frameworks. The infrastructure layer for AI agents continues to mature rapidly, with developers building increasingly sophisticated tools to bridge the gap between capable models and practical deployments. PipesHub emerges this week as an ambitious open-source alternative to enterprise search platforms like Glean, combining vector databases with knowledge graphs and agentic RAG to deliver what the developers call grounded results, meaning the system explicitly states when information isn't found rather than hallucinating answers. The platform connects to over 40 data sources including Google Drive, Gmail, Slack, Notion, Confluence, and SharePoint, deploying via a single Docker Compose command. What distinguishes PipesHub from simpler RAG implementations is its fully event streaming architecture powered by Kafka, enabling scalable, fault-tolerant indexing across large document volumes. The Agent Builder component extends beyond search to include action capabilities, sending emails, scheduling meetings, and conducting internet research. Community response highlighted practical concerns. One commenter asked about knowledge graph construction methodology, noting that existing tools like Neo4j's LLM Graph Builder struggle with documents beyond simple text-heavy content. Another questioned memory footprint for smaller deployments, a persistent concern for self-hosted solutions competing with cloud alternatives. The tooling ecosystem extends to machine control with RMCP Presence, a Rust-based MCP server consolidating 142 tools for AI perception and actuation into a single binary. The project spans sensors, system stats, USB devices, Git status, weather, actuators, clipboard, screenshots, file operations, and Linux-specific capabilities including window management, media playback, and per-application audio control. Feature flags allow users to scale permissions from read-only sensors to what the developer characterizes as full Linux God mode. On the infrastructure side, Plano launches as a framework-agnostic data plane for agentic applications, built on Envoy proxy technology to offload common delivery concerns from application code. The project addresses a complaint familiar to anyone deploying agents. Calling an LLM is straightforward, but managing model routing, guardrails, and observability across multiple agents creates substantial engineering overhead. For developers juggling multiple Claude code sessions, Claude Quick provides a terminal dashboard managing dev containers with automatic Git worktree creation and credential injection. And because it's a TUI, it works surprisingly well over SSH from mobile devices. The system project takes a different approach entirely, using Cloudflare workers as a remote brain for Mac control via natural language, with the actual machine control happening through a local bridge executing AppleScript and Raycast extensions. Model Control Protocol, MCP ecosystem. The MCP ecosystem faces a discovery problem. Useful servers get shared in discussion threads, then vanish as conversations scroll away. A new community index at aistack.dev attempts to preserve institutional knowledge by cataloging MCPs with maintenance status and setup documentation rather than simply aggregating links. The curator explicitly distinguishes this from existing aggregators like mcpservers.org and mcpindex.net by committing to ongoing curation, culling 404s, and noting which projects remain actively maintained. Domain-specific MCP implementations continue proliferating. FIBO-MCP introduces financial ontology support, equipping AI agents with a standard financial dictionary based on the Financial Industry Business Ontology Standard from the EDM Council. The project aims to explore methodologies for steering agents toward consistent answers in financial contexts, enabling what the developers describe as macro-level reasoning for financial tasks. While still maturing, the initiative reflects growing recognition that effective AI deployment in specialized domains requires more than raw model capability. It requires structured knowledge representation that constrains outputs to domain-appropriate vocabulary and reasoning patterns. Local LLM hardware and performance. The perennial AMD versus NVIDIA question for local LLM inference receives fresh attention as a user contemplates dual RX 9070 GPUs for Windows-based inference. The calculus involves familiar trade-offs: NVIDIA's It Just Works CUDA ecosystem versus AMD's price-performance advantage and approximately 50% faster gaming benchmarks. Community feedback reveals the current state of AMD support on Windows. Single GPU configurations work reasonably well with LM Studio and Ollama using Vulkan, with one user reporting 106 tokens per second on Qwen 330BQ4 using an R9732 GHz on Ubuntu. The consensus advice is to stick with Vulkan rather than ROCm, which shows minimal speed improvements for the additional setup complexity. Multi-GPU configurations remain less tested territory. The underlying concern persists. While AMD hardware theoretically supports inference workloads, the software ecosystem lags. As one commenter noted, the problem with buying AMD is that whilst in theory stuff can get ported, a lot of stuff either doesn't get ported or is late. For those willing to write HIP kernels themselves, the toolchain is reportedly robust, but that's a significant barrier for typical users. A practical head-to-head comparison between Claude Opus 4.5 and OpenAI Codex 5.2 on a real coding task, adding vector search to an MCP server, yielded an unexpected conclusion. Neither model won outright, but using both together proved more effective than either individually. The most valuable phase was cross-review. Codex identified bugs in Claude's plan, including contradictory specifications, both hard fail on missing credentials and graceful fallback, and a tool naming collision. The tester's takeaway: for architecture decisions and complex integrations, running plans past multiple models before implementation catches errors that single model workflows miss. The $200 a month question isn't which model is best, it's when a second opinion justifies the overhead. New model releases and capabilities. The Technology Innovation Institute in Abu Dhabi releases Falcon H1R7B, a reasoning-focused model claiming competitive performance against models 2 to 7x larger. The architecture builds on the Falcon H1 base with a two-stage training pipeline. Supervised fine-tuning on curated mathematics, coding, and science datasets using curriculum learning to prioritize challenging examples, followed by reinforcement learning with the GRPO algorithm to encourage high-quality reasoning chains within token budget constraints. The model introduces Deep Think with Confidence, DeepConf, during test time scaling, aiming for accuracy gains while generating fewer tokens than competitors. Benchmark results position Falcon H1R7B strongly in mathematics, leading the category against models up to 32B parameters, though the claimed 72.27% on math benchmarks should be evaluated against specific benchmark choices. Code and agentic benchmarks show similar patterns, with the 7B model reportedly outperforming Qwen 332B by approximately 7 percentage points on some measures. Whether these gains generalize beyond the benchmark suite remains the eternal question for new model releases. Meituan's Longcat image arrives as a 6B parameter bilingual Chinese-English image generation model, optimized for text rendering accuracy, particularly for Chinese characters. The model requires explicit quotation marks around target text for proper rendering. The tokenizer applies character-level encoding only to quoted content, and omitting quotes significantly degrades text quality. This detail illustrates how model-specific quirks persist even in production-ready releases. Tencent's HY World 1.5 WorldPlay pushes into real-time interactive world modeling, generating streaming video at 24 FPS with long-term geometric consistency. The system uses dual-action representation for keyboard and mouse input control, reconstituted context memory, to maintain consistency across long horizons, and a novel reinforcement learning post-training framework called World Compass. The technical report covers the full pipeline, including data preparation, training stages, and inference deployment optimizations. Applications span first-person and third-person perspectives in both realistic and stylized environments, with demonstrated capabilities in 3D reconstruction and infinite world extension. AI research and optimization. UC Berkeley researchers, in collaboration with Apple, ICI, and LBNL, address a fundamental inefficiency in LLM inference for reasoning tasks with arbitrage, a step-level speculative generation framework. The problem: while LLM training is compute-bound, autoregressive decoding is memory-bound. Each token generation relies on matrix vector multiplications rather than the more hardware-efficient matrix-matrix operations, creating a memory wall that limits throughput regardless of raw compute power. Traditional speculative decoding pairs a fast draft model with an accurate target model, having the draft generate multiple tokens that the target verifies in parallel. However, token-level speculation suffers from low acceptance rates in reasoning tasks. Minor discrepancies cause rejection of semantically equivalent reasoning steps. Step-level approaches like reward-guided speculative decoding, RSD, evaluate entire reasoning steps via process reward models, accepting drafts exceeding a global quality threshold. But RSD's fundamental flaw is routing based solely on whether the draft looks good enough, rather than whether the target model would actually produce something better. Arbitrage's key insight is advantage-aware routing, switching from draft to target model only when the target is expected to provide meaningfully better continuation. The acceptance decision considers not just draft quality in isolation, but the expected advantage between draft and target models for each specific reasoning step. This prevents costly target regenerations that yield minimal quality improvement, a common failure mode in existing approaches. The framework demonstrates that intelligent routing decisions at the step level can substantially reduce inference costs while maintaining reasoning quality, particularly valuable for long chain-of-thought solutions spanning hundreds or thousands of tokens. Section Development Tools and Security. A malware campaign exploiting VS Code tasks demonstrates how developer tooling itself becomes an attack surface when merely opening a repository can trigger code execution. The attack blurs the distinction between running untrusted code and reviewing code, a particularly concerning vector as developers increasingly clone repositories to evaluate AI-generated code or inspect open-source dependencies. The blog post detailing the campaign highlights how assumptions about passive code review don't hold when IDEs execute configuration files automatically. On the offensive security research side, OpenRT emerges as an open-source red teaming framework for multimodal LLMs with 37+ attack methods covering both black box and white box approaches. The plugin-based architecture supports text and image attack vectors with multiple evaluation strategies, including keyword matching and LLM-based judging. YAML configuration files enable reproducible experiment definition, useful for systematic safety testing, but also a reminder that attack tooling becomes increasingly accessible. ArsenalNG provides a modernized command launcher for penetration testing, offering 150+ cybersecurity cheat sheets with fuzzy search and variable templating. The Go-based rewrite emphasizes speed and developer experience, with features like color-coded syntax highlighting and persistent session variables that autofill across commands. Set target 10.10.10.10 once, and all subsequent commands with target placeholders populate automatically. The tool reflects broader trends in security tooling, making existing knowledge more accessible rather than developing novel capabilities. Section Prompt Engineering and System Analysis. Research into prompt compression takes an unconventional turn with experiments on symbolic instruction encoding, using mathematical symbols like up, ball, and what as instruction shortcuts without any system prompt explanation. The hypothesis: large language models have seen mathematical symbols millions of times during training, so these symbols already carry stable meaning that might function as compact instruction representations. Testing across 8 models from small open source to frontier APIs revealed inconsistent but intriguing results. Some models preserved instruction meaning up to 75% of the time using symbolic encoding. Certain operators performed excellently on specific models while failing completely on others. Mid-sized models often performed worse than both smaller and larger models, a surprising non-monotonic relationship with scale. The researchers' conclusion: prompts behave more like specifications than conversations, and some models demonstrate intuitive grasp of symbolic structure that could be exploited for compression if the model symbol compatibility is carefully validated. The LeakHub platform provides crowdsourced system prompt leak verification, maintaining a library of exposed system prompts with community validation. Meanwhile, the Digital Red Queen paper explores adversarial program evolution using LLMs to write red code warriors for Core War, a game where programs must crash opponents to survive. The research found convergent evolution, different code implementations settling into similar high-performing behaviors, mirroring biological patterns. The work positions Core War as a sandbox for studying adversarial dynamics in artificial systems, offering insights into how deployed LLM systems might compete for resources in real-world scenarios. Infrastructure and visualization projects. An interactive visualization of City Bike's complete history demonstrates the potential for browser-based data exploration of urban infrastructure datasets. The project joins a tradition of civic technology visualizations that make municipal data accessible without requiring specialized tools or technical expertise. Cloudflare's analysis of a BGP anomaly in Venezuela on January 2nd provides a detailed examination of route leak dynamics, contributing to public understanding of internet infrastructure vulnerabilities. The company's blog also covers React-to-Shell exploitation activity, noting that threat actors quickly integrated the RSC vulnerability into scanning routines targeting critical infrastructure, including nuclear fuel and rare earth element facilities. A reminder that infrastructure security extends far beyond traditional IT boundaries. On the IoT front, the Qingping Air Quality Monitor 2 receives a local MQTT modification guide, enabling Home Assistant integration without cloud dependencies. The Android-based device requires enabling developer mode via the classic 7-tap method, then ADB shell access to redirect cloud server calls to local infrastructure. The hack exposes amusing security details, SSH access with root and the password root. Community discussion noted the device's €150 price point versus DIY alternatives around €60 using ESP32S3 displays with SCD41 CO2 sensors, though building your own means trading money for time and accepting a likely inferior enclosure. For some, that trade-off is precisely the appeal.